Good morning, friend. In last lecture, we have completed the exercise 12.1, or we can say how to find out the area of triangle using equilateral triangle, isosceles triangle, and scalar triangle with ratio sum, and also how to find the cost. Now, today topic is related with the applications of Heron's formula. So where we can apply. Now already we in 8th standard we know that the types of quadrilateral, or we can say quadrilateral, rhombus, rectangle, parallelogram, kite. Everywhere we have to use this formula that is called Heron's formula. So it is called application of Heron's formula. Application means where we have to use. So quadrilateral, if you will see the quadrilateral, here someone asks to you, okay, how many triangles you have seen? If you will see properly, there are two triangles, that is 1 and 2. If you will see properly, here are two triangles we have seen. So what we have to do, we have to find out the area of two triangles, and then we have to add. It is called application of triangle. But here if you will see properly, two things we have noted it here. One, here in symbol, if it is not given, then we have to think that here it is 12, here it is 5. If it is 90 degree here, so we can say it is a right angle. How we can say right angle? Because in question it is given angle C is equal to 90. So when right angle triangle there, area of triangle half into base into altitude. Or we have to find out by using the triplet 12, 5 and 30. And then 9, 8 and 13. By using it we have to find out the, so first of all what we have to find out in triangle, question number 1, in triangle VDC, angle C is equal to 90 degree. So according to the Pythagoras, BD square is equal to BC square plus DC square. So BD square is equal to 12 square plus 5 square. 144 plus 25 is equal to 169. So BD square is equal to 169. So BD is equal to 13 centimeters. Now we can find out the area of triangle, that is ABD, and area of BD and C. So two area of triangles we have to find out. Now for area of quadrilateral ABCD. Area of quadrilateral ABCD is equal to area of triangle, that is ABD, plus area of triangle BDC. ABD and BDC. So area of quadrilateral ABCD, two areas of triangle we have to find out. That is ABD. So ABD. Here we have to find out 13. Already we have got it. Answer is 13 centimeter that we have got. Now 13 centimeter is there. ABD, BDC. How to find out ABD? Already we know that by using Heron's formula. So S is equal to, first of all, that is A is equal to given 9, B is equal to, we can say always big side you have to take as A, then B is a 9 and C is equal to 8 meter. Now we have to find out the S. It is lay with the triangle ABD. So S is equal to 13 plus 9 plus 8 upon 2. So here you will get answer 13 plus 17 plus 13, that is 30 divided by 2, that is 15. 15 meter is there. So I think everywhere meter, then we have to use the meter. If everywhere centimeter, we have to use the centimeter. So now area of ABD is equal to under root, that is 15, 15 minus 13, 15 minus 9, 15 minus 8. So we can get 15 into 2 into 6 into 7. Now to make a vector, you will get 3 into 5 into 2 into 3 into 2 into 7. So 3 is 2 times and 2 is 2 times. So we have to make outside. So 3 2 times come as a 3 and 2. 3 2 are 6 under root 7 5 are 35 under root 7 5 are 35 meter square. That is the area of ABD. Area of ABD. Now we have to find out area of VDC. So again A is equal to, we can take 13, B is equal to 12 and C is equal to 5 meter. We can do it by shortcut method, that is half into base into area. Also we can get answer same, half into base into height. We can get same answer. So 1 by 2 into 12 into 5, that is 30 meter square. But anyhow we have to, by using Heron's formula, we have to get same answer. So is equal to under root. So first of all we have to find out S. So S is equal to 13 plus 12 plus 5 by 2, that is 60 divided by 2, that is 30. Now under root 30, 30 area is equal to S, S minus A, S minus B. So 30 divided by 2, that is 15. 25 plus 5, 30 divided by 2, that is 15. So 15, 15 minus 13, 15 minus 12 and 15 minus 5. So if you will go through it, we can get answer 15 into 2 into 3 into 10. So if you multiply 15 to the 30, 30 into 3, that is 900. So answer is 900. So it will become out as a 30. So BDC is equal to 30 meter square. So area is equal to area of quadrilateral ABD plus DBC. So we have to add, that is 30 plus 6 root 35 meter square. Now under root 35 we can convert into, because in 8th standard we know the long divisible method to find out the perfect square. So 6 6 are 36 and 5 5 are 25. So our answer between 5 and 6. And we can do also 5.5. 5.5 is 30 point something. So it is near to 6 because it is, so approximately answer of it is 5.92. Root 35. So to find out root 35, we have to go by long divisible method. So here 5 into 5. Here we have to get 25. Then 2 0 I have to take. I point. I have to put 1 again. 0 into 0, so 9 into 9. So here it is 9. So 9 nines are 81, 8, 981. I have to add this. Again minus. So we get 90. Again 20. So I have to write 2 into 2. We can get 5.92. 8th standard method, long divisible to find out the square root. So we can get approximately 5.92, but this answer is also correct. And or we can write approximately 30 plus 6 into 9.2. So that is sufficient. Now in one more we have to do it. Again same type of sum now in exercise 15.2. In exercise 15.2, sorry 12.2, 12.1 area with the triangle. Now here it is quadrilateral, maybe possible rhombus, maybe possible rectangle. But concept is same, applications of Euron's formula. So one more sums we can do it by change the side. So we have to change the side and try to solve again one more sum for the application. So here sides are given, that is 5, 4, 5. 5 centimeter, again 5 centimeter, 4 centimeter, and 3 centimeter and 4 centimeter. I think you have to do it yourself because two triangles are there that you have to solve it. So try to solve this and give me the, or you can write in comment that you will get such answer. Again, I am saying to you, when you are visualizing the videos or you are going to the video, always remember that you have to write the important point related. So I think you have to try it yourself. So we can do it one more sum related. Now area of ABCD is equal to area of triangle ABD plus area of triangle BDC or BCD. Now we go through the two triangles are there. So area of triangle ABD. So A is equal to 5, B is equal to 5, and C is equal to 4. All are centimeter. Now S is equal to A plus B plus C by 2. So 10 plus 4, 14 divided by 2, that is 7. Now area of ABD is equal to under root 7, 7 minus 5, 7 minus 5, and 7 minus 4. So 7 into 2 into 2 into 3. So only 2 into 2, that will be come outside. Otherwise all are same. So 2 root 21 centimeter square. That is the answer of first. Now we have to do the second. That is area of BDC. Again I am saying to you, it's a one type of triplet. So we can get answer by using, here it is a right angle triangle, 3, 4 and 5. It's a triplet, 3 square plus 4 square is equal to 5 square. So it is called triplet. That already we have learned in 8th standard. 3 square 9, 9 plus 16, 25 is equal to 25. So it is a right angle triangle. So BD square is equal to BC square plus CD square. So we can find out the right angle triangle, area of right angle triangle, half into base into altitude. So here 3 into 4, that is 6 centimeter square. If we can use the Hero's formula, again we can get same answer. A is equal to 5, B is equal to 4 centimeter we have to write, and C is equal to 3 centimeter. Now under root S minus, first of all we have to find out S, that is 5 plus 4 plus 3 by 2, that is 12 by 2, that is 6. Now 6 minus 5, 6 minus 4, and 6 minus 3. So 6 into 1 into 2 into 3, that is under root 36 centimeter square. So 6 centimeter square. Area of BCD. So area of BCD is also 6. Area of ABD is 2 root 21. So total area, we can say area of ABCD is equal to 2 root 21 plus 6 centimeter square. Again root 21. When root 21 is there, how we can find out root 21? Perfect square method. So 4 into 4, 16. Here 4. So 16, 21 minus 6, 16, that is 5. Here we have to add 8. 2, 0 I have to take a point. So I have to make multiple. So approximately you will get answer something, that is 21, that is 4.6. So 4.6 I have to multiply by 6. 6 8 is 48, 4, 6 is 36, 3, 48, 6 is 48, and 5 and 2. So near to it is 59. 4.59, so 4.6. We can take 4.6 centimeter square. But answer is correct, no need to put under root 21. Mostly in board exam it is given. So in 12.2 there are more sums. Today we have discussed the basic related with the application and mostly in quadrilateral. In next lecture we can discuss related with the rhombus, parallelogram and others type of triangles.